Okay, so now that we have done with integrating product of sine and cosine functions, we are going to learn how we will be able to integrate powers of tan of x and sec of x. Yeah. So before discussing the integration of products and powers of tan x and sec x, it will be very useful to recall these basic integrals that involve tan x and sec x as you have done it in your, I think, okay, let's say, as I said, differentiation is the reverse of integration. So I assume that you have done it already and there are something that you must know. So if you know that the differential of tan x is equal to sec square x, then it means that the integral of sec square x should give us tan x plus the arbitrary constant of integration, which is c. So that is how we do it. So as I said, keep in mind that integration is a reverse of differentiation, right? So basically, if you know the differentials of these basic trigonometric functions, which is tan x, sec x, ln of sec x, and then other ones, you'll be able to do the reverse as well. So before we proceed, let's consider these ones, these basic integrals. So the first one, it's the integral of sec square of x dx, and then the integral of sec square x dx is equal to the tan of x plus c, where the c is the arbitrary constant of integration. So the second one that we would like to also talk about will be the integral of sec of x tan x or dx should also give you to be like sec x plus c. And then the third one can also be the integral of tan of x dx, which is equal to ln of sec of x, that is the absolute, the ln of the absolute of sec of x dx plus c. And then the fourth one that I would like us to also look at, it be the integral of sec of x dx should be equal to the ln of sec x, the ln of sec x plus tan x, tan of x, that's the absolute of it, plus the arbitrarily constant of integration, which is what, c. So these are some common integrals that you must know on your fingertips. So for most integrals of product and powers of tan x and sec x, we can rewrite the expression in a different form. So you can reach to integrate as the sum or a difference of the integrals of the form. Let's see something like this. For example, integral of tan power n of x and then sec square of x dx. Or you can also do it like, let's say sec power n of x and then tan x. So as you can see, we can evaluate these new integrals by using the U substitution to solve it. So whenever you get such integrals, the focus is to reduce it in either this form or this form, so that you can use U substitution to evaluate whatever you want to. So before we proceed, let's quickly look at some examples so that you can get a clear understanding as soon as possible. So to get a clear understanding, let's take a look at this example. So example 1. Evaluate the integral of sec power 5 of x and then tan of x dx. So this is it, and as I said, take note of these integral. We know that differential of tan x is sec square x, therefore integral of sec square x is tan x. Yeah. So we also know that the differential of sec square x is sec x tan x, and therefore the integral of sec x tan x is equal to sec x plus c. The next one is the integral of tan x is equal to ln of sec, or the ln of the absolute of sec of x plus c. And then as I said earlier on, how do we differentiate ln values? You differentiate this ln, whatever is inside, you put it at the numerator and you divide it by the function, whatever is inside first. So if we differentiate this place like this sec x, we are going to get sec x tan x divided by whatever is in the bracket, which is what? Sec x. Sec x. It's more or less, it's like more or less like ln of x. So ln of x is 1 over x, and this is how we do it. You differentiate whatever is inside the bracket, which is 1, and you divide by whatever is in the bracket, which is x. That's why you have 1 over x. So when you differentiate sec x, as we have done here, you get sec x tan x, and you divide it over whatever is in the bracket. So when you do it like this, you can cancel this sec x, sec out, and you are going to get what? Tan x. This is how you will confirm that this one is actually true. Therefore, the integral of tan x dx is equal to ln of the absolute of sec x. Excuse me. So let's take note of it. So the last one also talks about sec x. So when you integrate sec x, what are you supposed to get? So if you integrate sec x, sec x is the ln of, into bracket, the absolute of sec of x plus tan x, right? And then plus c. So this is these are some of the things that you need to know on your fingertips. So we're using them a lot, right? So now that you understand these ones, let's proceed with the question that we are solving. Now we have something like this: sec to the power 5 of x multiplied by tan of x dx. So when you look at these ones that you know, or I assume that you know, which of them is similar to whatever we are doing, right? You must know some relationship inside, and how do we identify them? So if you know such things will become easier for you to simplify, and you will not find yourself wanting. So let's quickly solve this question. As I said, integral of sec to the power 5 of x multiplied by tan of x dx. So in doing that, we will start by rewriting this sec to the power 5 of x multiplied by the tan of x as, right, we need to reduce this, so as sec to the power 4 of x, and then we have reduced it by 4 because it's an odd, right? And then sec x. So now when we multiply them together, we are going to get back this sec to the power 5 of x. And then don't forget that we have a tan x here, so we have tan x. So as I told you earlier on, if you manipulate the one with the odd power, we take u to to be the other, we take u to be the other one that we didn't manipulate. But in this case, it's the other way around. That's the integral of the product of sec x and tan x, and we will come to that. So now, when you do it like this, you can say that let your u to be equal to sec x. If it was in a trigonometric ratio like the trig one, which involves the cos and the sine, I always tell you that when you manipulate the other one, you pick the other one as your u. But this one, we pick the same thing or the same this thing that we have manipulated as your u, so that you can eliminate the other one. And as time goes on, you get to know the trend of which this aspect also follows. So now let's say that let our u equal to sec of x, and the idea is to eliminate this tan x in such a way that we will get everything in terms of sec x. And don't forget that our differential of sec x, we wrote it here, which is what? The ln of sec x plus tan x. The ln of sec x plus tan x. So let's look at this here. That's the integral. But the differential of sec x. So let's assume that these are our integral. So since the integral is the reverse of differential, it means that the differential, which is the y dx of this sec x, will give us sec x tan x. So now we are going to get what? Sec of x and then tan of x. So getting this, you can make the x the subject. And don't forget that since we said that let u equal to sec x, and then we find the u dx equal to sec x tan x, the whole function changes, or the whole question changes to be the integral of u power 5. And then multiply by what do you let's not put it u power 5, because we have actually, okay, I need to bring it here. Yeah. So the integral of u power 4 here, u power 4. And don't forget that we have sec x tan x dx. Now we want everything in terms of u, and we have our du dx equal to sec x tan x. What do? We make the x the subject. So in making the x the subject, we can say that then our dx is equal to du over sec x tan x. So having our dx equal to du over sec x tan x, we can replace it into the original question. So now we are going to get the integral of u power 4 multiplied by sec of x multiplied by tan of x, and then the dx now becomes du over sec of x tan of x. Now in this, you can see that there are some common terms inside, and therefore we can cancel them out. So when we cancel them out, what are we going to get? We are going to get something like the integral of u power 4 du. And trust me, this becomes very, very simple than the one which was given, which is sec to the power 5 of x tan x dx. And in this case, you can apply your power rule to solve this. So when you apply your power rule, you are going to get 1 over 5 u power 5 and then plus c, right, plus c. And then since you are plus c, remember that we said that let our u equal to sec of x, and therefore you can place it in as 1 over 5 into bracket sec to the power 5 of x, and then plus your c. So this is how we solve it. Let me give you a trial question for you to try using the same approach, and then check your answer as well. So the question is, this is a trial question. The question is evaluate tan to the power 5 of x and then sec to the power 2 of x dx. So this is a trial question that I want to give it to you, and then after you are done solving this, this is the answer that you are supposed to get. The answer that you are supposed to get is supposed to be 1 over 6 tan of to the power 6 of x plus c. So this is the answer that you are supposed to get at the end of the day. So please try your hands on it and then come and check your answer here. So thank you here, and my next tutorial is going to be like showing you some of the various strategies in solving the product of the tan and the sec functions.